Assalamualaikum and hi everyone. We will continue on topic 8 correlation and regression. But before that, let's recall what we had learned in lecture 1. So, in lecture 1, we already learned about 8.1 linear correlation. And then we also learned about find the Pearson product moment correlation coefficient, which is R. And we also had learned how to interpret the value of R. Next, let's proceed with 8.2 simple linear regression. So, please prepare your pencil, your calculator, and your module. Stay focused and aim A formats. Topic 8 Correlation and Regression. Lecture 2 of 3, 8.2 Simple Linear Regression. At the end of the lesson, you should be able to A. Determine the estimated parameter of the regression line using the least squares method y hat equals to A plus bx. B. Interpret the estimated parameter obtained. C. Use the estimated regression line to make prediction. In part A, we need to determine the estimated parameter of the regression line using the least squares method. What is regression? A regression equation is used to predict or estimate the relationship between dependent variable, which is y, and independent variable, which is x. For example, here we have you would like to find the relationship between maths and economy marks. Here, we need to use least square method in order to obtain the regression line. In practice, most relationships are not exact. There will be a certain amount of scatter about the line. We require the equation of the line that fits the data best. This could be done by finding the best fitted line using the least squares method. The best fitted line is known as a regression line, and we will write the regression line such as y hat equals to A plus bx. So this will be our regression line, which is y hat equals to A plus bx. Next, we need to determine the value of A and B. So this the formula for B. B equals to Sxy divided by Sxx. Let's recall what are the formula for Sxy and Sxx. The formula is here. So these are the formula for Sxy and Sxx. Please remember, n is the number of paired observation. How about A? The formula for A is A equals to y bar minus B times x bar. In other words, summation y over n minus B times summation x over n. You need to remember this formula in order to find the value of A and B so that you can write your regression line y hat equals to A plus bx. Next, for part B, we need to interpret the estimated parameter obtained. What are the parameters that we obtained just now? The parameter is the value of A and B in the regression line. When using a regression line, you can only apply the interpretations of the gradient, in other words, slope, and y-intercept over the range of x values. Your A is defined as y-intercept of the line represent the point where the line intersects at y-axis. In other words, we would say that when x equals to 0. And then for the value of B, B is represented as the value of gradient or slope. of the regression line represent the change in y for every 1 unit change in x. If your b gives you positive value, which means that y increased by b unit for every 1 unit x increase. In other words, we would have positive linear relationship. If your b gives the negative value, which means that y decrease by b unit for every 1 unit x increase, and it will be the negative linear relationship. So here you need to remember this interpretation. Let's move to part C, where we need to use the estimated regression line in order to make prediction. Predicted values of y for given values of x are obtained by simple substituting the value of x into the regression equation. It is inaccurate to make predictions or statements beyond the scope of what you observe in the dataset. In other words, there will be extrapolation data and interpolation data. What are the difference between extrapolation and interpolation? First, let's look at interpolation. If we are predicting for a value of x within the observed range, the prediction here should be fairly accurate. Whereas for extrapolation, if we are predicting for a value of x which is outside the range of the data, effectively, we are assuming that the linear relationship continues outside the observed range. Unless we have firm evidence to support this, we should treat this prediction very cautiously. From the graph here, it illustrates what mean by interpolation and extrapolation. First, let's look at the x dot here. If you can see, the x dot here is represent your observed data. And then, the dotted here is represent the predicted value. For example, here, we have the predicted value for A. If you can see, the predicted value A is within the observed data, which means that the predicted value for A is interpolation. Now, let's move to upper part here. Here, we have, for example, predicted value for B. If you can see, the predicted value for B is outside the observed data. So, it shows that the predicted value for B would be extrapolation. So, this is what it means by interpolation and extrapolation, where for interpolation, A is within the observed data, whereas for B, it is outside the observed data. That's why for B, we will have the extrapolation. Let's move to example 1. The summary of annual expenditures, which is represented by Y variable in RM1000, for 8 towns consisting of different number of families, which is our X variable, should be in 100, is as follows. So this would be the summary of the data. From the statement, you should know that your variable of Y is annual expenditures, and it should be written in RM1000. And then you have the value of N is equals to 8. Whereas the variable X is the number of families, and it should be written in 100. So the question is, you need to obtain the equation of the regression line represented by y hat equals to a plus bx with values a and b correct to 4 decimal places. Hence, you need to interpret the value of b. First of all, let's recall what are the formula in order to find b. So these are the formula. Sxy divided by Sxx. How to find Sxy and Sxx? So these are the formula involved in finding Sxy and Sxx. First of all, you need to find the summation of y because the question didn't give the value of summation x and summation y. From the information, we know that x bar is equals to 112.5. X bar is equals to summation x over n is equals to x bar. So from here, summation x is equals to x bar times n, which means that 112.5 times with 8. So the summation x would be equals to 900. Next, let's move to summation y. We are given the y bar is equals to 228.625. The formula for y bar is summation y over n is equals to y bar. In order to get summation y, we will have y bar times n. So in other words, we will have 228.625 times with 8. Press your calculator correctly, you will get the value of summation y, 1829. Next, let's proceed in order to find the value of Sxy and Sxx. Sxy is equals to, let's put all the summation into the formula. 255,150 minus with summation y times with summation x, or summation x times with summation y, 900 times 1829 divided by 8. Press your calculator correctly and you will get the answer for Sxy is 49,387.5. And then continue with Sxx. Put all the summation into the correct formula where you will have 126,550 minus with summation x square 900 in bracket square over 8. So the value would be 25,300. The formula for b is equals to Sxy divided by Sxx. So b is equals to 49,387.5 divided by 25,300. So the value of b would be equals to 1.9521. So this is the value of b. Since we get the value of b, next we need to find the value of a. The formula for a is equals to y bar minus b times with x bar. So a is equals to y bar 228.625 minus with b 1.9521 times with x bar 112.5. Press your calculator and you will get your a is equals to 9.0138. So this will be the value of a. And then your regression line, you will write such that y hat. Please remember you need to write y hat is equals to 9.0138 plus your B is 1.9521 and then X. So this will be your regression line. Please don't forget you need to interpret the value of B. So here, as you can see, the value of B is equals to 1.9521. The value of B is positive. So we would say that the annual expenditures increases by RM 1,952 ringgit and 10 cents for every increment of 100 families. If you can see here, we have the value of B 1.9521. So here, you need to convert or you need to times with 1000 since we have the unit in Y should be in thousand. So that's why 1.9521 times with 1000 and we will get 1,952 ringgit and 10 cents. For every increment of 100 families, why we have 100 here? Because the X variable, the unit is in 100. So that's why for every increment of 100 families. So here, the important thing is you need to know the unit for each variable. For Y, the unit is 1000. That's why our B should be times with 1000. Here we have RM because our Y is talking about annual expenditures. So the expenditures, the unit should be in RM. So that's why here we have RM 1,952 ringgit and 10 cents. Furthermore, for X variable, from the statement, the unit should be in 100. That's why in the interpretation of B, we need to put 100 families. So the interpretation for B is the annual expenditures increases by RM 1,952 ringgit and 10 cents for every increment of 100 families. For question B, we need to estimate the annual expenditure for a family living in a town consisting of 6,000 families. First of all, we all know that the unit for X variable should be in 100. Therefore, here we have our value of X would be 6,000 divided by 100. So, we will get our actual X would be equals to 60. We cannot use 60,000 because our unit for X is in 100. So we need to change in 100. That's why we have our X is equals to 60. And then our linear regression is Y hat is equals to 9.0138 plus 1.9521x. So here what we should do is we need to substitute when X equals to 60 into the regression line. So we would have Y hat is equals to 9.0138 plus 1.9521 times with 60. And you will get the answer is 126.1398. Please remember the unit for Y is in thousand. So here what you should do is you need to times with 1000. Then you will get the value of Y when X equals to 60 is RM 126,139 ringgit and 80 cents. Please remember to put RM in front of the values because our Y is about annual expenditures. So the unit should be in RM. Example 2. The following table shows the results of an experiment where 8 similar plots of land were given different amounts of water in centimeters and the resulting yield of paddy in tons per acre was recorded for each plot. So here we are given the variable x, which is the amount of water, and the variable y is the yield of paddy. First of all, you need to know your x variable and your y variable. The question asks you to find the equation of the regression line of y on x in the form of y hat equals to a plus bx correct to 4 decimal places. And then you need to interpret the coefficients of your regression line. First of all, you need to find all the summation. Please scan the respected QR code below in order to find all the summation. And then list out all the summation. After you list out all the summation, then let's look at the formula that we need to use. First of all, we need to find the value of B, where the formula for SXY and SXX is given here. And then after we find B, we need to find the value of A. And the formula as shown here. So, let's start with find the value of SXY. SXY is equals to, let's put all the summation into the formula. We would have 4,507.8 minus with summation x 680 times with summation y 49.97 divided by n is 8. Why 8? Because here we have 8 similar plots of land. So SXY would be equal to 260.35. And then let's continue with SXX. SXX would be equals to 66,200 minus with 680 square divided by 8. Press your calculator correctly and you will get the value of SXX is equals to 8,400. Then the value of B would be equals to 260.35 divided by 8,400 and your B is equals to 0.0310. Please remember, you should write the value of parameter A and B correct to 4 decimal places. Next, after that, we need to find the value of A. The value of A would be equals to A equals to 49.97 divided by 8 minus with 0.0310 times with 680 divided by 8. So the value of A would be 3.6113. So here we have the value of A and the value of B. Now we need to write our linear regression. So our linear regression would be y hat equals to 3.6113 plus 0.0310 x. So this will be our regression line. From A just now, we already get our regression line, which is y hat equals to 3.6113 plus 0.0310x. The next part, we need to interpret the coefficient of regression line, where we need to interpret coefficient for A and coefficient for B. So the interpretation for A is when there is no water added, then the yield of paddy is 3.6113 tons per acre. Here you should know that the interpretation for A is when x equals to 0. So for this case, our x represented as the amount of water. When there is no amount of water added, then the yield of paddy is 3.6113 tons per acre. So this is interpretation for A. Let's move to interpretation for B. Our value of B is 0.0310. So we would say that the yield of paddy increased by 0.031 tons per acre for every 1 cm amount of water added, which means that every increment in 1 cm of water, the yield of paddy increased by 0.031 tons per acre. So this is how we interpret the coefficient A and coefficient B. Question C. What would you expect the yield to be for a plot where 70 cm of water was added and for a plot where 190 cm of water was added? So here we have given two values of x, which is the first one, x equals to 70 cm, and here x equals to 190 cm. Let's recall our linear regression line, which is y hat is equals to 3.6113 plus 0.0310x. First, let's do for x equals to 70 cm. For x equals to 70 cm, just substitute x into the linear regression line. Y hat is equals to 3.6113 plus 0.0310 times 70. Just press your calculator correctly and you will get the value for x equals to 70 cm is 5.7813 tons per acre. Whereas for x equals to 190 cm, let's do the same. Substitute x into the y hat plus 0.0310 times with 190. Press your calculator correctly and you will get the value for y hat for x equals to 190, which is 9.5013 tons per acre. Then, for question D, we need to comment on the reliability of the results gained in C. From the observed data, we are given the amount of water started from 35 cm here up until 130 cm. So for x equals to 70 cm, if you can see from the observed data, x equals to 70 cm is within the range where it should be somewhere here. So 70 cm is within the range where it would be somewhere here. Therefore, the comment for x equals to 70 cm would be, since x equals to 70 cm is within the range, therefore the result is reliable because it is interpolation data. Let's look at for x equals to 190 cm. If you can see, the observed data is between 35 up until 130. So 190 cm will be outside the range. Therefore, the comment on this value of x would be for x equals to 190 cm, it is outside the range. Therefore, the result is unreliable because it is extrapolation data.